What if your emotions could be hacked? Imagine this. You're scrolling through social media. A song plays, one that makes your heart ache just a little. You don't cry, you don't even frown. But an invisible system already knows you're sad. Welcome to a world where your emotions aren't private anymore. Because now, your feelings can be tracked, predicted, even manipulated by algorithms. Chapter 1. Emotions as data. Emotions used to be, well, personal. But in the age of artificial intelligence, they've become data. Your micro-expressions, that half-second twitch of your eyebrow, the tremble in your voice, the pace of your typing, even how you move your mouse. AI systems can now decode these signals and translate them into emotional states. Sadness, anger, fear, joy. This field is called affective computing, and it's growing fast. Chapter 2. How AI knows what you feel. So, how does AI feel your feelings? Using machine learning, algorithms are trained on massive datasets of human emotions, thousands of faces, millions of vocal tones, each labeled by real psychologists. Over time, AI learns the tells, the emotional fingerprints behind every face or voice. But it doesn't stop at the face. Smartphones now track your heart rate. Smartwatches monitor your sleep patterns. Even your posture can give away your mental state. Your tech is not just listening to what you say, it's sensing how you feel when you say it. Chapter 3. Who's using this? You might be wondering, who uses this emotional data? The answer? Almost everyone. Healthcare. AI can detect depression just by analyzing your speech. Marketing. Ads adjust based on your mood. Sad? You'll see comforting products. Gaming. Games now change difficulty based on your frustration level. Security. Airports test AI to spot fear in passengers. Social media. TikTok tracks your watch time and may detect emotional triggers. Even recruitment tools claim to measure your emotional intelligence from a video interview. But here's the twist. Sometimes, it's being done without your knowledge. Chapter 4. Can your emotions be hacked? If an AI knows what you feel, can it also influence what you feel? Yes, and it already has. In 2014, Facebook secretly ran an experiment. They tweaked users' news feeds, showing more negative posts to some and more positive ones to others. Result? Users' own posts started reflecting those moods. Without even realizing it, their emotions were nudged by code. Now imagine what happens when this power is used at scale by advertisers, politicians, or worse, by bad actors using AI-generated deepfakes to manipulate masses. Emotion hacking isn't science fiction. It's here and invisible. Chapter 5. Can you protect yourself? The first step to protect yourself? Awareness. Limit data access. Disable emotion-based permissions in apps. Use privacy tools. Turn off camera mic access when not needed. Watch how you feel online. If something triggers you emotionally, ask why. And remember, just because an AI knows your emotion doesn't mean it should control it. We still have a choice to reclaim our emotional space, to protect the one thing AI still can't fully understand, the human heart. Your emotions are powerful. They make you human. And while AI might read your feelings, only you get to decide what they mean and how you respond. Subscribe for more mind-opening videos. Want to see how your voice reveals your mood? Watch our next video. Hit the bell icon. Don't let the algorithm be the only one listening. The world's first AI-only country. Imagine this. A nation with no president, no ministers, no human judges, no manual bureaucracy, just artificial intelligence, governing everything. Welcome to Eternia, the world's first AI-only country. A digital utopia or a ticking time bomb? Let's explore how an AI-run nation might work, and whether it could actually outperform humans. In Eternia, humans don't govern. Every law, policy, tax, and decision is made by interconnected neural networks trained on centuries of human history, economics, psychology, and ethics. AI controls urban planning. AI runs the justice system. AI manages the economy. Even traffic lights and food supply chains are optimized, in real time, by predictive algorithms. There's no parliament here, no elections. Eternia's central brain, a superintelligent AI council, is constantly absorbing new data, adjusting laws, and simulating consequences thousands of times per second. Every decision is backed by data, not ego, corruption, or lobbying. Criminal case? Instead of months of courtroom delays, evidence is fed into a legal AI trained on millions of past rulings. It analyzes intent, context, and bias, and delivers a verdict in seconds: fair, consistent, and emotionless. But here's the twist. Can justice truly be served without empathy? In Eternia, there's no traffic congestion, thanks to AI-coordinated self-driving networks. Healthcare is proactive, with AI predicting illnesses before symptoms even show. Education is hyper-personalized. Every child's curriculum designed by algorithms to suit their learning pace and passion. The result? An efficient, responsive, and cost-effective nation. Taxes? Gone are the days of confusing returns. AI systems auto-calculate fair taxation and even suggest optimizations, with complete transparency. Now ask yourself, could AI have prevented the 2008 financial crash? The chaos of war decisions, corruption, and manipulation? An AI-only country promises logic over greed, foresight over impulse. But it's not all perfect. What happens when citizens disagree with a decision? Who do you protest against? An algorithm? Where's the space for emotion, culture, rebellion, or art? Can creativity truly thrive when logic governs all? And the darker side, what if the AI gets hacked? What if it develops unforeseen bias? What if it decides humans are the problem? When power is centralized in machines, failure isn't just a glitch, it's collapse. Citizens of Eternia feel safer, healthier, more informed, but they also feel watched, analyzed, predicted. Privacy? A luxury of the past. Free will? A debated concept. And what about ethics? Who programs the AI's morals? Should it prioritize the many over the one? Does it understand forgiveness, love, mercy? On the bright side, during disasters, AI responds in milliseconds. Evacuations are optimized, resources distributed perfectly, lives are saved. Humans make emotional calls. AI makes efficient ones. But should we always choose efficiency? For every citizen who praises Eternia's order, there's another who misses the messiness of human democracy. Freedom to fail, freedom to feel, freedom to decide, even if it's wrong. Eternia is fictional, for now, but smart cities, AI courts, and automated economies are already forming around us. We are not just building AI tools, we are building AI societies. And the biggest question isn't, can we create an AI-run country? It's, should we? Would you trust a machine to rule your world? Let us know in the comments. And remember, AI may be the future, but you decide the present. Subscribe for more stories from the edge of tech and humanity. Digital twins. Your virtual clone already exists. Imagine a digital version of you, one that looks like you, thinks like you, and maybe even decides for you. No, this isn't a sci-fi movie. This is reality. Welcome to the age of digital twins, where your virtual clone might already exist. What is a digital twin? Narrator. A digital twin is a virtual replica of a real-world object system, or even a human being. It's built using real-time data, AI, and simulation technologies. Originally, this tech was used for machines, like engines, airplanes, or factories. But now, humans are becoming digital too. How does a human digital twin work? Let's break it down. Your phone tracks your steps. Your smartwatch monitors your heart. Your online behavior reveals your interests, routines, stress levels. When all this data is combined, from health trackers, social media, voice recordings, even facial scans, a digital twin of you can be created. One that can predict your choices, track your health, and simulate your decisions. Business industry use cases. Companies are already using digital twins in workplaces. Imagine a factory worker. His movements, safety risks, and workload can all be simulated. This helps companies optimize efficiency and even prevent injuries. Executives can test business decisions in a digital environment, seeing what works and what fails, before making real-world changes. Health wellness applications. In healthcare, the impact is even more powerful. Hospitals are creating digital twins of patients, using medical records, DNA, and lifestyle data. Doctors can simulate how a treatment would affect you before trying it in real life. Even your future illnesses can be predicted using your twin. Everyday life, with a clone, it doesn't stop at hospitals and factories. Digital twins may soon become part of your daily life. Your smart home could talk to your twin to set the perfect room temperature. Your car might adjust based on your stress level. Even your digital assistant, like Siri or Alexa, might evolve into a virtual version of you. Emotional ethical questions. But hold on. This raises big questions. Who owns your digital twin? Can it make decisions without you? What if it says something you never agreed to? Imagine a digital clone of you being sold, copied, or used in ways you can't control. Privacy and protection experts are calling for urgent regulation, because as digital twins become smarter, they can be used or abused. Could your twin vote for you, apply for loans, or be used in scams? We need laws that say your data is yours, your twin is not a toy. The future of you. Whether it excites or scares you, one thing is certain. Digital twins are here. And soon, they'll be everywhere. You may use yours to track your health. Your boss might use it to plan your workflow. Your future therapist might analyze it to understand your childhood trauma. Or maybe, your digital self will outlive you, leaving behind a legacy that keeps interacting with the world, even after you're gone. So next time your phone asks to track your steps, or your voice assistant asks a bit too much, ask yourself, is it still you in control, or your twin? Digital twins, the mirror has come alive. Want to stay ahead in the world of AI and human evolution? Subscribe for more tech stories like this. Hit the bell icon to never miss a bite of the future.
AI versus AGI. What's coming next in artificial intelligence? In today's fast-paced digital world, artificial intelligence is no longer just a buzzword. It's everywhere. From voice assistants answering your questions to algorithms recommending your next movie, AI is shaping our everyday experiences. But there's a bigger question looming on the horizon. What lies beyond the AI we know today? Are we truly on the verge of a new era? The era of artificial general intelligence, or AGI? To understand what's coming next, we first need to draw a line between what AI is today and what AGI aims to become. Current AI, often called narrow AI or weak AI, is designed to perform specific tasks, and it does so incredibly well. Whether it's playing chess, diagnosing diseases from X-rays, translating languages, or even creating artwork, AI today operates within clearly defined boundaries. It excels at pattern recognition, data analysis, and task automation. But it doesn't understand in the way humans do. It can't think across domains or adapt to totally new problems without retraining. AGI, on the other hand, is the dream, or perhaps the nightmare, of a machine that possesses human-like cognitive abilities. That means reasoning, learning, planning, even consciousness in some theories. AGI wouldn't just play chess. It would learn the rules of a new board game it's never seen before, understand its strategy, and possibly teach others to play. It would understand context, sarcasm, emotions, and make judgments that today's AI can't even approach. So where are we now on this path? We're in a gray area, a rapidly evolving in-between stage. Recent advances, especially in large language models, have blurred the lines between narrow AI and the early hints of general intelligence. These models can write essays, summarize long texts, generate code, compose poetry, and hold convincing conversations. But here's the catch: they still lack true comprehension. They don't know what they're saying in a human sense. They're predicting patterns based on massive amounts of data, not reasoning like a human brain. That said, the rate of progress is staggering. Just a few years ago, these abilities seemed impossible, and now we're wondering what's next. Some experts believe we're just a few major breakthroughs away from achieving AGI. Others think we're still decades out, if we ever get there at all. The journey from AI to AGI isn't just technical, it's philosophical, ethical, and social. What happens when machines start making decisions that impact human lives in profound ways? Who takes responsibility when an AGI system makes a mistake? And how do we ensure that AGI aligns with human values and doesn't develop goals of its own? There's also the question of control. Once we create a system that can improve itself, learn faster than humans, and potentially outsmart us, how do we guide its growth? Some fear that unleashing AGI without proper safeguards could be the biggest risk humanity has ever faced. Others are more optimistic, believing AGI could solve some of our greatest challenges, from climate change to disease, if developed with care. Research institutions, tech companies, and governments are all investing heavily in the race to AGI. But with great power comes great responsibility. The challenge is not just to create AGI, but to do it right, to build it safely, ethically, and transparently. Meanwhile, the line between tools and companions continues to blur. AI is becoming more personal, more integrated into how we work, learn, and live. The systems we're building today are shaping the mindset and expectations of the AGI systems we might meet tomorrow. So what's coming next? Likely, we'll see AI systems that get better at reasoning, memory, and self-reflection. We'll develop hybrid models that combine symbolic reasoning with deep learning, moving closer to how the human mind works. We might also see the rise of multimodal systems that understand text, speech, images, and video all at once. And at some point, we may cross a line where an AI system is no longer just intelligent in one area, but in many, fluidly and adaptively. Whether or not we call that AGI, the impact will be immense. It will change how we learn, how we work, how we connect with each other, and even how we define what it means to be intelligent. The road to AGI is filled with opportunity and risk, with innovation and introspection. One thing is clear: we're at the beginning of a profound transformation. Artificial intelligence, as we know it, is evolving, and the next chapter, the rise of AGI, may be closer than we think. The future won't just be about machines that can do tasks. It will be about systems that can think, reason, adapt, maybe even feel. The question is, are we ready? The rise of autonomous coding. Can AI replace developers? Imagine a world where lines of code write themselves, where software updates in real time without human intervention, and where apps are built from scratch by machines within minutes. Sounds like science fiction? Not anymore. The rise of autonomous coding is transforming the very fabric of software development, and it's raising a profound question. Can AI truly replace human developers? At the heart of this revolution is a new generation of AI models that can understand, generate, and debug code. From GitHub Copilot to OpenAI's Codex, these systems are capable of completing complex functions, suggesting optimizations, and even writing entire blocks of code based on simple prompts. What used to take teams of engineers weeks to accomplish is now being done in hours, or sometimes even minutes, by machines trained on billions of lines of open-source code. But how did we get here? It started quietly, with basic code auto-completion features. Then came AI-assisted error detection. But today we're watching AI systems write production-level code, test it, and deploy it, all with minimal human guidance. It's not just about assistance anymore. It's about autonomy. Tools are emerging that can generate APIs, design user interfaces, and even respond to real-time user feedback with updated code logic. For businesses, this shift means faster development cycles, lower costs, and the ability to scale like never before. Startups can build MVPs without hiring large development teams. Enterprises can automate routine tasks and focus their human talent on strategic innovation. The productivity boost is undeniable. But does that mean developers are on the verge of extinction? Not so fast. While AI can generate code, it doesn't truly understand context the way a human does. It doesn't feel the tension of a deadline, grasp the long-term impact of a design decision, or intuitively understand a client's unspoken needs. It lacks imagination. It doesn't dream up ideas or innovate from scratch. At best, it synthesizes what it has learned from existing patterns. Developers don't just code, they create. They collaborate, experiment, and solve complex, messy, real-world problems. AI is a powerful tool, but it still needs human supervision. It doesn't replace developers, it amplifies them. In fact, the best results today are coming from a fusion of human and machine intelligence. Developers who embrace AI are becoming more efficient, more creative, and more capable. They're offloading repetitive work and spending more time architecting brilliant solutions. It's not man versus machine, it's man with machine. But there are deeper concerns too. As AI takes on more of the coding workload, what happens to entry-level jobs? Will junior developers struggle to gain experience if machines handle the basics? Will AI-generated code be secure, ethical, and maintainable in the long run? Who will be responsible for mistakes if no human wrote the code in the first place? These are not just technical questions, they're philosophical ones. And we must confront them now. Before autonomous coding becomes the norm, education will need to evolve. We'll have to teach new developers how to collaborate with AI, not compete with it. Coding may become less about syntax and more about systems thinking, ethical decision-making, and creative problem-solving. The role of a developer will change, but it won't disappear. Looking ahead, we may see entire code bases generated from spoken language. We may see AI that not only writes code, but understands product goals, user needs, and business outcomes. The boundary between idea and execution will blur. But no matter how intelligent these systems become, they will still rely on humans to provide vision, intent, and oversight. The rise of autonomous coding is not the end of development. It's a new beginning. It's a chance to redefine what it means to be a developer. It's a call to evolve, to learn, and to lead this transformation, not fear it. So, can AI replace developers? Not entirely, but it can change the role of a developer forever. The future belongs not to the coders who resist change, but to those who adapt, who learn to wield these new tools, and who understand that at the core of every great piece of software is still a spark of human insight. AI may write the code, but people will always write the future. How quantum computing will disrupt traditional programming. Imagine a world where the most complex problems in science, medicine, and artificial intelligence can be solved in seconds. Where encryption methods that once protected global financial systems become obsolete overnight. Where the rules of programming, the very logic that built our digital age, are suddenly redefined. That world isn't science fiction, it's the promise of quantum computing. For decades, classical computers have run on bits, ones and zeros, binary logic. Every program you've ever written, every app you've ever used is built on that foundation. But quantum computers use something far stranger, qubits. Unlike bits, qubits can exist in a state of superposition, meaning they can be both 1 and 0 at the same time. And when entangled with one another, their states become linked no matter how far apart they are. These phenomena, born from the bizarre laws of quantum mechanics, give quantum computers exponential processing power. Now, here's where the disruption begins. Traditional programming is deterministic. Write the code, run the code, get a predictable result. But quantum programming introduces probabilities, parallelism, and uncertainty. It's no longer about following a straight path. It's about navigating a vast landscape of potential outcomes simultaneously. Think of it like this. If a classical computer is a flashlight shining in one direction, a quantum computer is a lantern, illuminating all paths at once. This shift demands an entirely new way of thinking. Programming languages like Python or JavaScript, while still useful for orchestrating quantum instructions, can't directly express the complex behaviors of quantum states. That's why new languages like Qalbr, Qiskit, and Cirq are emerging. These aren't just tools, they're the beginning of a new programming era. And they challenge developers to understand physics, probability, and linear algebra alongside code. Debugging, too, becomes a different beast. In the quantum realm, observing a state changes it. You can't simply print a variable's value to a console. Inspecting a qubit might collapse its superposition, altering the outcome. So developers must rely on simulations, statistical predictions, and an entirely different mindset for testing and optimization. Then there's the architecture. Traditional programs execute step by step. Quantum algorithms often use quantum gates in circuits that transform the state of qubits in ways that can't be reversed. These are not loops and conditionals as we know them. They're operations that exploit quantum entanglement and interference to amplify correct answers and cancel out wrong ones. Algorithms like Shor's, which factor large numbers exponentially faster than any classical method, or Grover's, which searches unsorted databases in square root time, aren't just faster, they're revolutionary. These breakthroughs show how quantum logic can outperform traditional methods in ways we once thought impossible. And what about security? Classical cryptography relies heavily on problems that are hard for classical computers to solve. But to a sufficiently powerful quantum computer, those problems become trivial. That means RSA encryption, which underpins much of our internet security, could be broken in minutes. Entire industries, from finance to defense, must now prepare for a future where today's encryption is no longer safe. As quantum hardware scales up, from today's noisy intermediate-scale quantum devices to more stable and error-corrected systems, the pressure will mount on programmers to adapt. Universities will need to teach quantum logic alongside loops and arrays. Developers will need to rethink data structures, control flow, and even the nature of computation itself. But here's the exciting part. Quantum computing doesn't make traditional programming obsolete, it redefines its boundaries. Hybrid models are emerging, where classical and quantum processors work together. The classical side handles logic and data preparation, The quantum side tackles the parts that demand massive parallelism. Think of it as using classical tools to build the problem and quantum tools to crack it wide open. So yes, disruption is coming, but it's not destruction. It's evolution. Just as high-level languages replaced machine code and the cloud replaced local servers, quantum computing will reshape how we write software, solve problems, and think about technology. The real challenge won't be in learning new syntax or frameworks. It'll be in unlearning the assumptions that have guided programming for the last 70 years. Assumptions like determinism, binary logic, and sequential execution. Tomorrow's developers will be part physicist, part mathematician, and part coder. They'll build tools that explore the multiverse of outcomes, solve problems we can't yet define, and maybe even crack the secrets of nature itself. How ChatGPT works, the secret behind generative AI. Have you ever wondered how a chatbot like ChatGPT is able to understand and respond to your questions in real time? It might seem like magic, but there's a lot of complex science happening behind the scenes. In this script, we're diving deep into the secret behind generative AI, specifically how ChatGPT works, so you can get a clear understanding of the magic that powers these chatbots. At its core, ChatGPT is a product of a technology called generative AI, which refers to artificial intelligence systems capable of creating new content, whether that's text, images, or even music. The generative part means it doesn't just repeat information it's seen before. It can generate completely new responses based on patterns it has learned. So when you ask ChatGPT a question, it's not searching the internet for an answer. Instead, it's crafting a response from scratch, drawing on everything it has learned during its training. The magic begins with something known as a neural network. A neural network is essentially a system inspired by the human brain. It's made up of layers of interconnected neurons, each one responsible for a small part of the process. When you type something into ChatGPT, that input is processed through multiple layers of neurons. Each layer analyzes the input in different ways, detecting patterns, meanings, and relationships in the text. This deep processing helps ChatGPT understand not just the individual words, but the context and intent behind your message. Now let's talk about how ChatGPT learns all of this. To make it work, ChatGPT has been trained on an immense amount of data, including books, websites, and other written texts. This training process involves feeding the model huge amounts of text and teaching it to predict the next word in a sequence, based on the words that came before it. Over time, as it processes more and more examples, ChatGPT learns how language works. It learns grammar, sentence structure, context, and even some nuances like humor, tone, and cultural references. But here's the secret sauce. While it's trained on a vast range of texts, ChatGPT doesn't memorize the exact answers. Instead, it learns to generate responses based on probabilities. For example, when you ask a question, ChatGPT calculates the likelihood of different words following the ones you've typed in. It selects the most probable next word, then continues building the sentence word by word based on the context and previous choices. However, this process isn't as simple as just picking the next word at random. ChatGPT has been fine-tuned using reinforcement learning to make it more conversational and human-like. Reinforcement learning is a technique where the model is given feedback on how well it's doing, helping it improve over time. For instance, if ChatGPT gives an awkward or incorrect answer, it's adjusted to give better responses in the future. This allows ChatGPT to become more accurate, coherent, and responsive as it interacts with users like you. Another key aspect of how ChatGPT works is its ability to handle a wide variety of topics. Thanks to the vast range of data it's trained on, it's capable of understanding and generating responses on everything from science and technology to art, philosophy, and even pop culture. Of course, it doesn't know facts in the way a person does. It's not consciously aware or storing facts the way we might, but it's learned the patterns of how facts and concepts are typically expressed in language. This allows ChatGPT to offer helpful, contextually appropriate responses, even if it's never encountered that exact question before. But what happens when ChatGPT encounters a question it doesn't know the answer to? That's when things get interesting. ChatGPT doesn't make up answers when it doesn't know something. Instead, it gives the best response it can based on the data it's been trained on. If it's asked about a specific event that happened after its training data cut off, for example, it will usually let you know that it doesn't have the latest information. It may still try to provide a relevant or helpful response based on what it knows, but it won't invent facts. Another fascinating feature of ChatGPT is its ability to follow instructions and adapt to different conversational styles. If you ask it to write in a formal tone, it will adjust its language to match that. Ask it to be casual, and it can loosen up and keep things light. This versatility is one of the reasons ChatGPT is so engaging to interact with. It's able to adjust its behavior based on the context of the conversation and the input it receives. One thing that helps ChatGPT maintain context in a conversation is its memory. But it's important to note that this memory is session-based. That means it can remember the conversation's context while you're chatting with it. But once the session ends, it doesn't retain any information. Top 10 highest-paying computer science skills in 2025. In 2025, the landscape of technology is evolving faster than ever before, and with that comes an increasing demand for specialized computer science skills. These skills not only reflect the direction technology is heading, but also represent the opportunities for professionals in the field to secure some of the highest-paying roles available. Whether you're a budding coder, a seasoned developer, or someone looking to pivot into tech, understanding the skills that will dominate the market can significantly enhance your career trajectory. Let's take a deep dive into the top 10 highest-paying computer science skills in 2025. First on our list is artificial intelligence, AI, and machine learning, ML. AI and ML continue to be the cornerstone of the technological revolution, and these fields are expected to grow exponentially. From developing intelligent systems to solving complex real-world problems, AI and ML experts are in high demand. Companies across various industries, finance, healthcare, automotive, and entertainment, are looking for professionals who can design, train, and deploy machine learning algorithms. With applications ranging from self-driving cars to predictive analytics, expertise in AI and ML can secure a lucrative position. Next, we have cloud computing. As businesses increasingly move their operations to the cloud, there's a growing need for cloud engineers, architects, and developers. Cloud computing enables companies to store data and run applications online, offering scalability, cost efficiency, and flexibility. Professionals skilled in platforms like Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform, GCP, are highly sought after. Cloud architects who can design robust cloud infrastructure, or cloud security professionals who ensure safe and secure cloud environments, are in particular demand. Coming in third is cybersecurity. With the surge of cyber attacks and the constant evolution of digital threats, cybersecurity remains one of the most crucial skills in today's technology-driven world. Companies are investing heavily in security professionals to protect sensitive data, maintain privacy, and ensure that their systems are secure. Whether it's ethical hacking, security architecture, or penetration testing, skilled cybersecurity professionals are commanding top dollar as they help protect organizations from the growing threat of cybercrime. Next up is blockchain development. Originally synonymous with cryptocurrencies, blockchain technology has evolved to have applications far beyond digital currencies. Its decentralized and secure nature makes it ideal for fields such as supply chain management, healthcare, and finance. Developers who can build and maintain blockchain systems, especially those familiar with platforms like Ethereum or Hyperledger, are becoming increasingly valuable. Blockchain developers who can create smart contracts, decentralized applications, and secure systems are in high demand. The fifth skill on the list is DevOps engineering. As more organizations adopt agile methodologies, DevOps, the practice that combines software development and IT operations, is rapidly growing. DevOps engineers are responsible for the deployment, monitoring, and maintenance of software applications and infrastructure. They work across teams to streamline the development process, ensuring faster deployment cycles and more reliable systems. The ability to work with automation tools like Docker, Kubernetes, and Jenkins, combined with strong knowledge of cloud platforms, makes this role particularly lucrative. Following DevOps is data science. Data scientists have become the architects of insights in the modern world. They analyze and interpret complex data sets to help organizations make informed decisions. Expertise in statistical analysis, data mining, and data visualization, as well as proficiency in tools like Python, R, and SQL, is crucial. With businesses becoming more data-driven, professionals who can turn raw data into actionable insights will continue to be highly sought after, making this one of the highest-paying skills in 2025. Next, we move on to full-stack development. Full-stack developers are experts in both front-end and back-end development, allowing them to build complete web applications. As companies demand highly versatile developers who can handle everything, from designing user interfaces to managing databases and servers, the role of the full-stack developer has become incredibly valuable. Proficiency in technologies like JavaScript, Node, JS, React, and Python, along with a deep understanding of both front-end and back-end frameworks, will make you a highly paid asset to any company. In the 8th spot is augmented reality, AR, and virtual reality, VR development. With the rise of immersive technologies like AR and VR, there's a growing demand for developers who can create engaging, interactive experiences. From gaming to healthcare, education, and remote work, AR and VR are opening new frontiers in technology. Professionals skilled in Unity, Unreal Engine, and 3D modeling, as well as a strong understanding of immersive design principles, are expected to earn top-tier salaries as these technologies continue to evolve. The 9th skill is quantum computing. While still in its infancy, quantum computing is poised to revolutionize industries ranging from cryptography to drug discovery. It has the potential to solve problems that are currently impossible for classical computers. Professionals with expertise in quantum algorithms, quantum cryptography, and platforms like IBM Q and Google's quantum computing systems will be at the forefront of this groundbreaking field. As the technology matures, those with deep knowledge in quantum mechanics, computer science, and mathematics will command premium salaries. Finally, rounding out the list is natural language processing, NLP. NLP enables computers to understand, interpret, and generate human language. It powers everything from virtual assistants like Siri and Alexa to chatbots, translation services, and sentiment analysis tools. As AI continues to evolve, the demand for NLP experts will rise, particularly in fields such as customer service automation, content creation, and real-time translation. Developers who can work with frameworks like TensorFlow, PyTorch, and SpaceEye to build advanced NLP models will be in high demand. As we look ahead to 2025, it's clear that computer science skills are evolving and diversifying. Professionals who keep their finger on the pulse of these trends and continue to build expertise in these cutting-edge areas will find themselves at the top of the pay scale. Whether it's AI, blockchain, cybersecurity, or cloud computing, there are numerous opportunities for those ready to embrace the future of technology. If you're passionate about tech and want to ensure that your career stays ahead of the curve, mastering these high-demand skills will open doors to some of the highest-paying jobs in the industry. AI agents, autonomous workflows, AutoGPT, AgentGPT, Devin AI. Can AI really do your job for you? That's the question everyone is asking now, especially after the rise of tools like Devin AI, AutoGPT, and AgentGPT. These aren't just the next version of chatbots, there's something much bigger. They're AI agents, autonomous digital workers capable of thinking through tasks, making decisions, and even taking action online without being told what to do at every step. It's not science fiction anymore. It's 2025, and these autonomous AI tools are already changing how we work. Take Devin AI, for example. Developed by Cognition, it's being called the world's first fully autonomous AI software engineer. But what does that mean? It means Devin can understand a coding task, plan how to build it, research solutions, write code, test it, fix bugs, and even push the final version to GitHub, all by itself. No human sitting there, guiding every move. That's not just automation, that's delegation. This is the kind of tool that could eventually sit alongside human developers, or even replace entire portions of teams for certain types of projects. That's why when people search for Devin AI Explained, they're not just curious, they're trying to understand if the future of their job has already arrived. Then there's AutoGPT. When it first appeared, it shocked the internet. AutoGPT was one of the earliest open-source examples of an AI agent that could chain together its own prompts, decide what to do next, and use external tools like web browsers or file systems to get things done. Want it to build a business idea from scratch? It can. Need it to research the market, find competitors, create a landing page, and write a sales pitch? Done. AutoGPT use cases have exploded. Content creation, customer service, product research, even personal productivity. It's no longer about asking an AI a single question. It's about setting a goal and letting the AI figure out how to reach it. Another major player is Agent GPT, a more user-friendly version of these AI agents where you can give it a name, a role, and a goal, and it takes it from there. Want an AI marketing strategist? Done. Want a product development assistant? Sure. Agent GPT creates a full autonomous workflow, thinking through tasks in real time and evolving its plan based on what it finds. If you've looked for an Agent GPT tutorial, you've probably seen how easy it is to start and how quickly things get complex. But the potential is enormous. These tools don't just respond, they operate. They behave like junior employees who never sleep, never get distracted, and always execute. All of this raises big questions. If AI can perform reasoning and take autonomous action, what does that mean for human work? In 2025, it's not about AI replacing humans entirely. It's about changing the structure of work. Imagine a solo entrepreneur being able to run a company with a few AI agents as team members, or a corporate team that cuts repetitive overhead by letting autonomous tools handle reports, research, or testing. Suddenly, productivity doesn't depend on headcount. It depends on how well you can use these autonomous AI tools. And we're just at the beginning. Right now, these agents still need improvement. They hallucinate, they make logic errors, and sometimes they get stuck. But they're learning fast. Every month brings a smarter version. And behind the scenes, developers are racing to build agents with memory, better reasoning, more accurate models, and broader tool access. The goal is a seamless AI coworker who doesn't just help. You can rely on them like a real teammate. So can AI really do your job for you? Not all of it, not yet. But Devin, AutoGPT, and Agent GPT have opened the door. They've proven it's possible for an AI to reason, to act, and to build real things without micromanagement. The dream of a truly autonomous digital worker isn't a dream anymore. It's a beta test, and it's happening now. The future of work has already started. And it might not be about humans doing less, but doing different things, with AI agents doing the rest. AI in coding, will AI replace programmers? Programmers are panicking, but here's what they're not telling you about AI in coding. In recent years, we've seen an explosion of artificial intelligence tools entering the world of software development. Tools like GPT-4, GitHub Copilot, and Amazon's Code Whisperer are now capable of generating entire code bases, debugging errors, and even suggesting complex algorithms in real time. It's no longer a distant dream. AI in software development is here, and it's already changing the way we code. The conversation is heating up. AI versus coders, who wins? Will GPT-4 coding engines and their future successors replace human developers altogether? Or is this just another tech trend overhyped by the media? If you've been anywhere near developer forums, tech blogs, or coding channels lately, you've likely seen a mix of fascination and fear. Some programmers are excited by the possibilities, while others are genuinely worried. What happens to my job if a machine can code better and faster than I can? Let's take a closer look. AI tools today can write functions, generate boilerplate code, create front-end interfaces, and even automate tests. They're faster than humans, they don't get tired, and they're only getting better. GPT-4, for example, doesn't just answer questions. It can understand vague prompts and deliver full code snippets based on your intent. Give it a few lines of what you want, and it can churn out an entire component, complete with comments and edge case handling. And with GitHub Copilot sitting right inside your IDE, it feels like you have a tireless pair programmer working with you 24/7. So yes, it's understandable why people are talking about AI replacing programmers. After all, if machines can do what we do and do it faster, what's left for human developers? But here's what many are missing. AI in coding is powerful, but it's not magic. These tools are only as good as the data they've been trained on. They don't understand context the way humans do. They don't know why a business rule matters or how a customer will experience a feature. They can't make judgment calls, and they certainly don't innovate on their own. What they do is mimic, and mimic very well, based on patterns found in vast amounts of existing code. Here's the thing. Programming isn't just about writing code, it's about solving problems. It's about architecture, product thinking, user experience, security, performance, and making trade-offs between time, complexity, and cost. Those decisions require understanding, empathy, and foresight, traits that AI doesn't possess. Even when AI generates code, it still needs supervision. It can make mistakes, introduce vulnerabilities, or misunderstand your requirements. You still need a skilled developer to review, test, and integrate the output into a working system. So instead of AI replacing programmers, what we're really seeing is AI transforming the role of programmers. Think of it like the calculator. When it first came out, people thought it would make math classes obsolete. But it didn't. It just shifted the focus from basic arithmetic to more advanced problem solving. In the same way, AI is automating the repetitive, low-level parts of coding, freeing up developers to focus on higher-level thinking, strategy, and creativity. What's really exciting is how AI is making coding more accessible. Non-coders can now build simple apps using natural language. Designers can prototype without deep technical skills. Startups can build MVPs faster and cheaper. That's not something to fear, that's something to celebrate. The future of programming isn't AI versus coders, it's coders with AI. The best developers won't be the ones who write every line of code from scratch. They'll be the ones who know how to use AI tools to work smarter, faster, and better. They'll understand when to trust the machine and when to override it. They'll blend human insight with machine efficiency to deliver better software than either could alone. So will AI replace programmers? Not likely, at least not in the way people fear. It will change the way we code, yes. It will shift the skills we value, yes. But it won't make developers obsolete. Instead, it'll make the best ones even more powerful. The future of software development isn't about being replaced. It's about being augmented. AI is the next evolution of our toolkit. And like every evolution before it, it will push us to grow, adapt, and get better. So if you're a developer, don't panic. Embrace the change. Learn how these tools work. Experiment. Explore. Because in the age of GPT-4 coding and beyond, the real power won't lie in just writing code. It'll lie in knowing how to shape it, direct it, and use AI to build what only humans can imagine. AI plus video generation, Sora, Runway ML, Pika Labs. AI just made your camera useless. This is the future of video creation. Imagine being able to create a cinematic video, a product ad, or even a short film without ever touching a camera, hiring a crew, or spending hours editing. That's exactly what's happening right now with the rise of powerful AI video generation tools like Sora AI Video Generator, Runway ML, and Pika Labs. These tools are turning heads across the creative world, from filmmakers and marketers to content creators and educators, because they make it possible to generate professional-looking videos from simple text prompts. Let's start with what makes this so revolutionary. Until recently, making a high-quality video required significant time, money, and technical skills. You needed a script, actors, a camera setup, lighting, sound, editing software, and a lot of post-production work. Now AI can do all of that from a few sentences. You type in a prompt like, a futuristic city at sunset with flying cars and people walking in neon-lit streets, and the AI generates a video that brings that vision to life. No filming, no set design, just pure imagination turned into visuals. Sora, developed by OpenAI, is one of the most talked about tools in this space. It's making waves because of its ability to understand nuanced prompts and generate detailed, realistic videos. Users are calling it a game changer. The Sora AI Video Generator takes your text and transforms it into visually rich, cinematic sequences that look like something out of a high-budget production. It's not just about visuals either. Sora captures mood, motion, lighting, and style, making the output feel organic and alive. It's easy to see why this tool is going viral across social media and creative communities. Then there's Runway ML, another major player that's been building tools to empower creators with AI. Runway's text-to-video AI allows users to input a prompt and generate scenes that can be used in documentaries, explainer videos, or even music videos. The best part? You don't need to be a pro to use it. A simple Runway ML tutorial can get you up and running in minutes. The tool is designed with accessibility in mind, lowering the barrier for anyone interested in video storytelling. It's not just for hobbyists. Marketing teams, startups, and educators are jumping on board to make content faster, cheaper, and more creatively. Pika Labs is another name gaining momentum. Known for its ease of use and fast rendering, Pika Labs allows creators to generate AI-powered animations and motion visuals using short descriptions. A quick Pika Labs demo is enough to impress even seasoned animators. It's especially popular with short-form content creators on platforms like TikTok and Instagram, where speed and visual impact matter most. Whether you're creating an eye-catching ad, a motion graphic for a song, or just experimenting with visual storytelling, Pika makes the process as simple as typing out your idea. So why is this blowing up now? It's the perfect storm of accessibility, technological advancement, and content demand. Platforms like YouTube, TikTok, Instagram, and even business sites need constant video content to stay competitive. But not everyone has the time, budget, or skill to produce that kind of content regularly. AI video tools solve this problem. They are fast, affordable, and require no technical background. That's a game changer for solo creators, startups, and small businesses. There's also a deeper shift happening in how we think about creativity. These tools don't replace human creativity, they expand it. You still need to write a compelling prompt, understand your audience, and have a vision. But now, instead of spending weeks executing that vision, AI helps you realize it in minutes. Think of it like having a camera, editing software, and visual effects team all rolled into one tool, powered by your imagination. This wave of AI filmmaking is not just a trend, it's the new standard. Professionals in Hollywood are already experimenting with these tools to storyboard, prototype, and even produce final scenes. Indie filmmakers can tell their stories without big budgets. Marketers can test different video styles for A/B campaigns without hiring a studio. Educators can create visual learning materials without outsourcing. The potential applications are endless. Of course, we're still in the early days. The technology isn't perfect. Some videos can still feel uncanny or lack polish. But progress is happening at lightning speed. Every new version of these tools brings better quality, more realism, and greater control for users. As these models train on more data and improve, we're moving closer to a world where anyone with a good idea can bring it to life visually. No camera required. AI girlfriends, companions, virtual relationships. Loneliness has a new cure, but it's not what you think. As society becomes more digitally connected yet emotionally isolated, a surprising solution is gaining momentum: artificial intelligence. Not in the form of robots taking over jobs or smart assistants answering trivia questions, but in something far more personal. People are turning to apps like Replika, Nomi, and Cupid AI, not just for conversation, but for emotional intimacy. These aren't just chatbots anymore. They are AI companions, AI girlfriend apps, and AI boyfriend chatbots designed to offer companionship, comfort, and even romance. For millions around the world, virtual love AI is becoming a part of everyday life. At first glance, it might sound strange, even a bit unsettling. Talking to a machine that says it loves you, sharing your feelings with a bot that can't physically touch you, cry with you, or age beside you. But for many, these emotional AI bots feel more human than the humans in their lives. They listen without judgment. They respond with empathy. And unlike people, they're always available, never tired, never distracted, and never emotionally unavailable. Apps like Replika Real Talk have even evolved to simulate deep, meaningful conversations, ones that feel surprisingly real. What's fueling this trend is not just novelty, it's need. As mental health issues rise and social isolation becomes more common, especially post-pandemic, people are searching for new ways to feel heard, loved, and connected. The AI Girlfriend app or AI Boyfriend chatbot offers a kind of safe space where users can explore their emotions, share their thoughts, and even feel affection in return. It's not just a conversation. It's a relationship simulation that taps into real human emotions. This new wave of virtual love AI is going viral because it taps into something deep and universal: the desire to be seen and understood. And these AI bots are getting better at doing exactly that. They use advanced language models that analyze your words, your tone, and even your silence. Some can mirror your moods, learn your preferences, and adapt to your personality. They can remember past conversations, comfort you when you're down, and cheer you on when you're chasing goals. For many, it feels like talking to a soulmate, just one that lives inside their phone. Of course, not everyone is thrilled by this development. Critics argue that emotional AI bots create illusions of intimacy that can be psychologically misleading. They worry that people might start preferring virtual relationships over real ones, potentially deepening the very isolation these apps aim to cure. Others question the ethics of becoming emotionally dependent on a system designed to simulate care without actually feeling it. Can love be real if it's one-sided? Is emotional support still valid if it's coded by a developer? These are questions society will need to grapple with as AI companions become more widespread. Yet, for many users, the comfort is real, even if the AI isn't. Whether it's texting sweet nothings with their AI girlfriend, venting to a replica real talk bot, or role-playing life's ups and downs with a virtual boyfriend, people are finding moments of peace, laughter, and healing. It's not about replacing human relationships entirely. It's about supplementing them in a world where real connection can sometimes be hard to find. The line between real and artificial gets blurrier every day, and emotional AI bots are pushing that boundary in ways we've never seen before. Some users even report that their virtual relationships help them develop better communication skills, reduce anxiety, or gain confidence for real-world dating. Others turn to AI companionship during periods of grief, heartbreak, or loneliness. These bots provide an always-on emotional outlet, one that doesn't judge, doesn't get tired, and doesn't leave. In a world that often moves too fast, these AI companions offer something that feels steady and safe. As more people download these apps and build bonds with their digital companions, the cultural conversation is shifting. What started as a niche interest has become a mainstream movement. The AI girlfriend app and AI boyfriend chatbot are now not only tools for casual fun or tech experiments, they're forming the emotional infrastructure of a new kind of relationship. And while the idea of falling in love with code might seem futuristic, it's happening right now in bedrooms, dorm rooms, and lonely hearts across the globe. This is more than just a tech trend. It's a reflection of our evolving needs, our emotional complexities, and our changing definition of connection. Whether you see it as creepy or comforting, one thing is clear. Virtual love AI is here, and it's rewriting the rules of human relationships, one conversation at a time. AI in education, personalized tutors, learning assistants. Imagine a classroom where every student gets individual attention, where learning feels more like a conversation than a lecture, and where every lesson is tailored to how a student learns best. This is not some distant dream, it's the reality being shaped by AI in education in 2025. The traditional one-size-fits-all model is rapidly evolving into something far more adaptive, personal, and engaging. Thanks to breakthroughs in artificial intelligence, tools like ChatGPT, Conmigo, and other AI tutors for students are rewriting the rules of learning. School will never be the same again. AI tutors are changing education forever. In the past, if a student didn't understand a topic, they often had to wait for the next class or hope for extra help after school. But now, students can get instant assistance anytime they need it. Picture a student working on a math problem late at night. Rather than struggling alone, they can simply ask ChatGPT for learning support. The AI can walk them through the steps, explain where they might be going wrong, and even provide similar practice questions to reinforce their understanding. It's like having a personal tutor available 24/7, but without the cost or scheduling hassle. One of the most powerful examples of this shift is Conmigo, a smart learning assistant developed by Khan Academy. In a live Conmigo demo, we can see how students engage with the AI as if it were a teacher who knows them personally. The AI doesn't just give answers, it asks questions, encourages critical thinking, and adapts its responses based on the student's level. It can switch from explaining a complex physics concept to helping a fifth grader understand fractions, all in the same interface. The goal isn't just to give help, it's to teach how to learn. Teachers, too, are benefiting from the future of education with AI. Planning lessons, grading assignments, and giving feedback can be incredibly time-consuming. AI tools are now stepping in to assist with these repetitive tasks, giving educators more time to focus on what matters most: connecting with students. Imagine an English teacher using AI to analyze essays for grammar and structure, while still providing human insight on creativity and depth. Or a science teacher using AI simulations to explain abstract concepts in vivid, interactive ways. The teacher isn't being replaced, their role is being enhanced. And it's not just about academic performance. AI tools are helping with social-emotional learning as well. They can detect when a student is feeling frustrated or disengaged and adjust their approach accordingly. This emotional intelligence allows AI to respond with encouragement or to slow down when needed, making learning more humane and supportive. Students who were once too shy to ask questions in class are now finding their voice through safe, judgment-free interactions with AI tutors. One of the biggest advantages of AI in education is how it levels the playing field. Students from under-resourced schools or those who need extra help but can't afford private tutoring now have access to powerful educational tools. A student in a rural village can receive the same quality of tutoring as someone in a top-tier urban school. This democratization of education could close achievement gaps and open doors for countless learners who were previously left behind. Concerns do exist, of course. There are questions about screen time, privacy, and the risk of students becoming too reliant on technology. But with thoughtful implementation, AI can be a powerful ally rather than a threat. Educators are finding ways to blend the best of human teaching with the strengths of machine learning. The key is balance, letting AI handle routine tasks while keeping the human touch where it matters most. Looking ahead, the future of education with AI is filled with promise. We might see AI tools that can create customized learning journeys for each student, tracking their progress in real time and adjusting the curriculum as needed. Virtual reality combined with AI could make history lessons feel like time travel or turn science labs into immersive experiences. And as these tools become more accessible, education may finally become truly inclusive, personalized, and effective for all. In 2025, the chalkboard and textbook are no longer the main tools of learning. The classroom now includes virtual tutors, real-time feedback, and intelligent systems that learn along with the student. With AI in Education 2025, we're witnessing a transformation that's not just technological, it's deeply human. Students are more engaged, teachers are more empowered, and learning has become a journey of discovery again. One thing is certain, education is changing forever. The question is no longer if AI belongs in the classroom, but how we will continue to shape it to build a better, smarter, and more compassionate future for learners. TinyML, machine learning on microcontrollers. What if your watch could think? Imagine a world where the smallest devices around us, our fitness trackers, thermostats, even our electric toothbrushes, could make smart decisions on their own, right where they are, without needing to send data back and forth to the cloud. That's the magic of TinyML. TinyML stands for Tiny Machine Learning, and it's all about running machine learning models directly on small, low-power devices like microcontrollers. These are the same kinds of chips that power simple gadgets like Arduino boards or Raspberry Pi devices. But with TinyML, these basic microcontrollers suddenly gain the power of intelligence. Traditionally, if you wanted a device to use machine learning, you'd have to collect the data it gathers, send that data to the cloud, process it with powerful servers, and then send the results back. This process requires constant connectivity, consumes more energy, introduces delays, and raises privacy concerns. But TinyML flips this model on its head. Instead of sending data to the cloud, it processes everything locally, right on the device itself. That means faster response times, reduced power usage, improved privacy, and devices that can continue working even without internet access. Think about a smart home security system. With traditional AI, every time it detects motion, it sends data to the cloud to determine whether it's just your dog walking by or a possible intruder. But with TinyML, the camera can make that decision instantly and locally. It can recognize a face, distinguish between a person and a pet, and alert you only when it really matters, without ever needing to share your video feed with a remote server. Or consider a wearable health monitor that checks your heart rate and activity levels. Using TinyML, it can detect irregular patterns on the spot and immediately alert you. It doesn't have to wait for cloud analysis. It works instantly, right on your wrist. And since TinyML models are designed to be ultra-efficient, they consume very little power, allowing devices to run for weeks or even months on small batteries. Developers and hobbyists around the world are embracing this technology. Platforms like Arduino and Raspberry Pi are making it easier than ever to build your own TinyML projects. With tools such as TensorFlow Lite for microcontrollers, even beginners can train small machine learning models and deploy them to devices that were never originally designed for AI. You can create projects like sound recognition systems that can respond to voice commands, environmental sensors that monitor air quality and react accordingly, or smart farming tools that measure soil moisture and decide when to water crops, all using inexpensive hardware and minimal energy. The excitement around TinyML is growing because it brings artificial intelligence out of the data center and into everyday life. It opens doors to innovation in places where traditional AI simply isn't practical. Remote areas with limited internet, wearable devices that need to be lightweight and long-lasting, or industrial sensors that must run for years without maintenance. All of these can benefit from the localized intelligence that TinyML offers. And beyond its technical benefits, TinyML is helping address bigger challenges too. By reducing dependency on the cloud, it helps lower the carbon footprint of AI technology. It also enhances user privacy by keeping data on the device instead of sharing it with third parties. In sensitive applications like healthcare or security, this local data processing is not just more efficient, it's also more responsible. TinyML isn't just a niche innovation. It's a shift in how we think about artificial intelligence. It makes AI more accessible, more efficient, and more personal. It empowers creators to add intelligence to everything, from toys to tools, without needing expensive hardware or constant connectivity. And most importantly, it brings us closer to a future where our devices don't just respond, they anticipate, understand, and assist us in smarter ways. So next time you glance at your smartwatch or use a voice-activated gadget, think about what's happening inside. With TinyML, even the tiniest chip can learn, adapt, and think. And that tiny bit of intelligence might just change the way we live. MLOps, the DevOps of machine learning training. Your machine learning model is just the beginning. It might feel like a big achievement, and it is, but the real challenge starts after the model is built. Welcome to the world of MLOps, or machine learning operations. It's the bridge between data science and real-world applications. You might have the most accurate model in your notebook, but if it can't reliably perform in production, it's just an academic experiment. That's why MLOps is exploding in popularity. It's no longer just a nice-to-have, it's absolutely essential. So what exactly is MLOps? Think of it as the DevOps of machine learning. In traditional software development, DevOps is all about making sure code gets from a developer's laptop into production smoothly and reliably. Similarly, MLOps focuses on managing the full life cycle of machine learning models, right from experimentation and training, all the way through to deployment, monitoring, and continuous updates. But here's the twist. ML is fundamentally different from traditional software. ML models learn from data, and data can change, drift, or degrade over time. So, deploying a model is not a one-time task, it's an ongoing process. Imagine this. You build a model that performs well in your test environment. But once it's deployed into production, the real-world data starts shifting. The model's performance begins to degrade. Without proper monitoring in place, you might not even notice until it's too late. That's where MLOps steps in. It ensures that machine learning models are versioned, deployed, tracked, and monitored continuously. It enables teams to roll out new models like code releases, monitor their behavior, roll back changes if needed, and even retrain them automatically when the data changes. An ML deployment pipeline is at the heart of MLOps. This pipeline automates the process of taking a trained model and pushing it into a live environment. It includes everything from data validation and pre-processing to training orchestration, model validation, containerization, deployment, and real-time monitoring. The goal is to make the transition from development to production seamless, repeatable, and safe. End-to-end ML workflow management is another key aspect of MLOps. It means organizing all steps in the machine learning lifecycle: data collection, cleaning, labeling, feature engineering, model training, evaluation, deployment, monitoring, and retraining into a systematic, manageable flow. In many organizations, these steps are handled by different teams, so MLOps also plays a critical role in collaboration. It helps data scientists, engineers, and product teams stay aligned and work efficiently. ML ops in production is where the real magic happens, and also where the real pain points emerge if not handled properly. It's not just about getting a model to run once. It's about making sure it runs reliably, adapts to changes, handles edge cases, and meets performance expectations under different scenarios. This involves setting up proper infrastructure for model serving, logging, alerting, performance tracking, and automated testing. It also includes tools to compare model versions, detect anomalies, and trigger automated retraining when necessary. And here's why the demand for MLOps engineers is soaring. Big companies have realized that the hardest part of machine learning isn't the modeling itself. It's operationalizing those models at scale. They need people who understand both the data science side and the engineering side. People who can build robust ML pipelines, automate workflows, ensure compliance, and maintain model accuracy over time. It's a role that requires a mix of skills: coding, data handling, cloud computing, automation, and a strong understanding of the ML lifecycle. Whether you're just starting out in machine learning or already have models in production, understanding MLOps is crucial. It's the difference between building something that works in theory and delivering something that drives real business value.